Hi guys, welcome to another video of my YouTube channel. So in this video we're going to see like the facade which you see in the cover image. We're going to see how to make this facade in Rhino and Grasshopper. So especially I'm going to use Grasshopper for this tutorial with the standard components. Don't need any add-ons or any plugins to create this facade. It's like a parametrical, which you will see. So let's proceed with the tool. So if you don't subscribe, if you didn't subscribe, just do it. It will be so helpful for me to do more videos in the future. Gun. So you can see the tool is over in the and in this you can see it's over there. So let's create like a number. I want like a 50 to 50 and with the size of 20. I don't know. Let's see. Okay. Now we created like a series of hexagon, which is the base to create the facade. So technically we are going to create something like a fidget spinner structure, like a fidget spinner facade where you can control it based on the curvature of like an attractor. So I don't want this hexagons to be created on the floor, that is on the XY plane. I just want to create like vertically. So what I'm going to do is like I'm going to change the plane. You can see there is option called plane. So what you can do is you can change the orientation. So let's say like X set plane. That's cool. You got it. So we have it here, but I don't think it's too much. Let's say like okay. Yeah, okay. This one looks pretty much better. And now what I'm going to do is, so technically we are going to make something like this. Okay. Please excuse me for the drawing. I'm trying my best to make you understand with the drawing by using a mouse. So it's the best I can draw with it. So technically what I'm going to do is I'm going to make this like a fidget spinner, as I said before. Like something like this, okay? So one edge of the hexagon comes in and the other edge goes out. But the thing is the same is being followed. Like you can do it for a hexagon, but in this hexagon also, this point should go out and this point should come in. So it should form the same shape all around like an infinite loop. So that's what we're going to do it. Let's keep this drawing aside, maybe. So as I said before, we need to merge. So to create this curve, we need the middle point and we move the middle point either outward or inward towards the center of the hexagon. That's the goal of the first major step. So to do that, I need to explode it. So you can see like each hexagon has like each row and column is been separated by the branch, which I don't need it. So I'm going to flatten it, and here you can see the point. I just need to flatten it because the flat. I'll just show you why I'm flattening it here as well. So now we have the segment of each hexagon, and all the segment is being segregated in separate branches. So let's simplify this, and let's say like I'm just going to take the middle point. Okay, this is perfect. But if you see here, like there's like 1049 branches, like each hexagon is in one single branch, something like that. So maybe I can reduce the number a little bit, because 1000 is like I can increase the size of the hexagon, which makes it more convenient and it will reduce the computing time. So you can see like it's 447 branches, like 0, 1, 2, 3, 4, 5, 6. But here if I like let's say like if I don't flatten, you can see like it's also in branch, but you see 31 because like each row of hexagon center points is being in like one branch. So each row or column, like It's been like that, but I want everything in one single branch, like one branches each. So what I'm going to do is I'm going to flatten it. So like you have a list of points. Now I'm going to use the point parameter and then I'm just going to graph it. So like you can see each point is being stored in a separate branch, which matches the middle point branch data, which matches the middle point data too. Now what I'm going to do is I'm going to create a 2-point vector, which like, okay. So technically, I'm going to move the middle point. That is my ultimate goal. So to move this point towards the input, I need a direction, which I got it using the vectors. So let's say like display. You can see it's been moving like this, which is cool, right? Sorry. Okay, this is what I need. So what I'm going to do is, so I have the vectors right now, but as I said before, I can't move it everything inside. I want like one inside, one outside, one inside, one outside. So I need that kind of movement, like inside and outside. What I'm going to do is, let's say like 1 minus 1, something like this. Yeah. And now yes, repeat data. So what this 1 and minus 1 is, like is 1, it will be the same vector. Minus 1 will flip the vector. So what I'm going to do is, I'm going to create a same data structure with this value repeating. So what I'm going to do is, like I'm going to create list length. So you can see like I'll just simplify. So you can see like each branch has 6 values. So technically like 1 minus 1, 1 minus 1, 1 minus 1. So it's in this kind of structure. It has like this kind of values, like which matches with the vector numbers. So I'm going to just multiply this, and you can see it's being multiplied, which is like, now I'm going to use amplitude. I'm going to use a vector over here with a value of 10 maybe. So now you have some points, but I need to create an arc. So what I'm going to do is, let's say I'm going to take the endpoints over from the segment, and you can see like everything is selected. So what I'm going to do is, like I'm going to take the endpoints and middle points. So I'm going to create a list with 3 points: start, middle, and end. So middle I'm moving. So technically, like it creates list. So how can I create it? I'm going to merge it. But when I merge these things, so it will be like a list of 6 plus 6 plus 6, which is like 18 in one single list, which won't create nothing. Like it creates like a mess. So what I'm going to do is, I'm going to graph everything like geometry, start, end. So what I'm going to do is, you can see here, you can see the first list as 0, 0, 0. So if you don't know what it means, like three branch, look here, like just show you what it means. So you can see like one set of 3 points is being stored in one single branch. So like a sub branch. So first all the 18 is stored in one branch. Then it creates another sub branch where these 3 points are separated into 6 different sub branches. If you want, you can see it here. Okay, it's too much. Maybe I can reduce the number to see it. but I can show you with interpolate, or you can use knobs. It's your choice. I think I don't want to explain you the difference between interpolate and knobs, if I'm not wrong. What is happening here? Okay. The moving point should be in the middle, and end point should be in this. Okay. Now you got it. Like, okay. I'll just hide everything. Let's see. Yeah. We got some kind of boomerang. Like, not the boomerang, I forgot, like a fidget spinner. That's cool, right? Okay. You can change the value however you want. So if you see here, like it's been connected. So there is two curves in this sector, like 1 and 2. I'll show you. That's the hexagon. So you can see here it's two curves because one edge is of this hexagon, another edge of this hexagon. So it is connected in a way that it moves like only outside for both edges. So now the challenging part is we need to create like a, maybe let's say like I'll just use okay, let me take this curve. I just draw it manually. But if you have some mathematical equation, you can draw it by yourself. So I want this curve, like I want how do I say? I want the amplitude. Like for example, if you see like this is like 0, which is like a normal hexagon, and it goes to a fidget spinner. So I want like the fidget spinner towards when it goes near to the curve, and on the far it goes, the far it becomes like an hexagon. So I want that kind of attraction. So in this case, the difficult part is like not the difficult. The tricky part is here is like because it's been moving, you might have different value of distance. So what I'm going to do is I'm going to take that like I'll just show you. So where's the curve? Curve is here. I'm going to use curve closest point. So usually people do here is they used to take the closest point of the center, but I'm going to use the closest point of the middle point, which makes it like pretty much easier. So now what I'm going to do is you have the point and you have the distance. So what I'm going to do is I'm going to remap the distance. So let's say like bounds and construct domain. So let's say like the same value of, let's say like the closer it is, it should be like more fidget, like move. So in this case, you have a value like something like this. Let's try to give it like so. Yeah, you can see here, like the closer. Okay, I'll just turn it off and I'll turn. Okay, this curve is good. You can see the closer it is, the more fidget, and the more it's moved, it's like you can see the kind of external creation. Like okay, so what happens when I give the middle point? Okay, so you can see it looks okay, good. But when you see here, like it has two different values because from the center, like for example, if this is the center and it takes this value from here to here, and the same way this is the center, it like from here to here, the distance is different. So the values like the amplitude is moved based on the distance we derived from the curve closest point. So when we use the middle point, so the middle point of this curve, like the curve, it's like it will just see follow my mouse, okay? The curve, it's like it's equal. So that's why I'm using the middle point. So now we have like I'll just hide this. I'll just make it to I'll just make it to middle point. So now we have something like this. Okay, I'll just delete this. And now let's clean a little, not too much. And if you see, there are some green lines in between my script, like which helps me to align the component. That is called Snappy Geeko. Snappy Geeko is a plugin which gives you to which allows you to to align the plugin in a very easy way, and you will see the guidance much more easier apart from the standard aligning method in the Grasshopper, which is really useful. You can give a try. I will just give you link for that. It's in Food for Rhino. You can use it like package manager. Like you can say like package manager here, and you can Geeko, this one. So it provides like multiple options of mapping, which is really cool. Okay. So now we have like something like this. So let's say like I just want to see the curve. Now what I'm going to do is I'm going to alter the curve. You can see the changes, and you can also put a minimum value of like 5, so you don't want to see like fully hexagonal. As well as if you see here, if you make it to 0, you see at this point it's like kind of hexagonal shape, which you are not a great fan of it. Like you want a minimum value which is being moved, so you can use this. Or else you can play with, there are like multiple options. You can offset it, or you can scale it. Like there are like multiple options to do it. Now what I'm going to do is I'm going to see the curve. I'm going to flatten this up. It's already created. No, if you see here, each curve is in a different branch, so I need to join it. So first I need to break the branch from tree, because each one, instead of flatten, if it's flattened, then everything becomes a list, which is a mess. So I just want to remove one branch, so you get like 6 curves in a single branch, which allows me to join into closed curve. So now we have something like this. Now you need to flatten it. So it's been flattened. Ta-da! Okay. Now what I'm going to do is I'm going to create like offset. Let's say like offset curve. And it takes some time. My computer is very old. Let's say like I want a thickness of 10. And it will be -6 because the offset is being done inside. As I said before, my computer is like kind of slow, so I hope I'll try to edit it out. I'll make it so that it is little faster in the video at least, so you can see an offset version is being created. Now, see the joining, let's say if I'm creating a surface, it doesn't make sense because nothing will be this much accurate joining. So I give a tolerance now. I'll just see Ctrl-C and Ctrl-V. Obviously it takes some time. My computer is like very old. Maybe I need to change it in the future. So I'll just give you like a 0.5. So it creates a tolerance, So now you can see I'll just hide these two things. So you can see it creates a tolerance. So there's multiple way to create a surface like this. But what I'm going to do is let's say boundary surface. Let's use boundary surface to create this. And because we are not there are a lot of things with trimmed surface it won't work. I just need to change the evaluate. So sorry. There are a lot of things won't work in the trimmed surface. So, but hereafter, after this, I'm not going to use this surface for evaluate. So that's why I'm using this option, because this option is not a good solution because it provides you a trimmed surface, which is not a great thing to do it, but you get something like this, you see. So Now I'm just going to extrude it. And it's going to be like, maybe let's say like it's in the, I just want to make it in the positive direction. So let's say like it goes like unit y, or like, yeah, why not? That's y, sorry. And I give a value of maybe like 100. Okay. So now we have a solid extrusion, which is cool. So now what I'm going to do is, like in the image, if you see, it won't, like, it's like, okay, I can give you a custom preview, which is much more good to, not this one. I don't like this. Custom preview. Yeah. So let's select render. I'll just turn this up. You can see, like now it looks like a jolly pattern or something, but it's like flatter. Okay, it looks like flatter. But what I'm going to do is like, okay, I'll just say like maybe 5. I don't see the gradation, so I'll just do 5, so that I can see the attractors. You can use multiple curves, for the attractors. For now, I'm just using a single curve to make it a little more simpler. Obviously, my computer, it takes some time to make this. Now you see, like it is like flat. But if you see in my cover image, it was like something like a bubble, like each one in a different extrusion. So what I'm going to do is, I'm going to let's close this. Okay, so I'm going to use a bounding box. Bounding box. It's here. Deconstruct. I'm just pause the computer. So what this is like, this will like log the like solver, and you just need to recompute whenever you do some changes. Okay, so I'm just going to flatten it, and I'm going to create a union box to get the outer boundary of the overall 2D structure. Okay, I'm going to like what is it? Construct interrupt, so which deconstruct it, and I'm going to choose one surface from it, like one face, and then I'm going to extract the curve of the face. Or like, I don't need a curve, maybe I'm okay with the surface. So what I'm going to do is, we can populate 2D region. So now what I'm going to do is, I'm going to create a populate for now. Let's say, or else, let's say like I'm going to, so now what I'm going to do is, I'm going to divide the surface. So you can see, like by mistake I use the surface and you don't. So in this case, usually like sometimes if you by mistake, if you did the wrong connection, it creates a huge lag. So in this case, it don't create a huge lag. So when I just enable it, you can see the difference, which is a pretty useful tool, but you just need to know the component which you are planning to use, and you already know the output before, so that it's much more easier to do the compute things. Okay, so now we have this. So we have like around, let's say like 231 points, which is like not bad. So I'm just going to move the points. I'm just flatten it in unit y direction. So what I'm going to do is I'm going to create a random value, random something for now. So, and I'm going to use the list length to get how many numbers of value I need. So it gives me like 231. It has 231 points. That's cool. So what I'm going to do is like I'm going to set a range. I'm lazy to create type this. Let's say like I'll use the same range over here. Like, not the same, like I'm lazy to put all the components back. So that's why I copied it. So now I like 231. You can see the points have been moved. So let's say like you have some movement over here. What I'm going to do is I'm going to surface from points. Yeah. So I'm going to flatten this and I'm going to use a UV count here. And this one goes like x plus 1. So I create some kind of wave structure. You can see it's kind of a wave like kind of surface. It's like it's totally random. You can like you can change the seed like however you want. Okay. Maybe if you want, I can reduce the point a little bit so that it's easier to control. 250 maybe, like, yeah, okay, this one looks cool. Yeah, okay, this is cool. And now, if you see here, like, let's say, like, because I will give 250 here because the maximum value is 250 here. So the extrude should be much more bigger than the surface so that I can cut it out. So now you can see, okay, we have this kind of structure over here. So now my goal is to cut the structure with the surface. Let's see how it works. So for that you can use multiple options. I'm going to use this one. So I'm going to extrude this unit y-axis. Delay. Let's say like x into 2. Like that. So I just cut it out with the solid which I created with the structure which is already there, like the hexagonal thing. So like it's a basic Boolean operation. So it can be any surface, like you can create like a wave, or you can create like it's like a sharp, like how do you say, like a wave, or a lot of options are there. So what I'm going to do is I'm going to hide this and see how it like looks. Okay, not bad. You can see. So let's say like shit. Back, okay. But okay, what I can do is I'm just going to give the 250 here, and let's say like x plus 5, so that it looks like parametric. And now what I'm going to do is let's say like 100, which is like pretty much a decent amount. I think 250 is too much. So then you can like you can play with it. So this is like an option where I created the pattern using a simple hexagonal concept, and then I created an attractor. Then I use like a basic Boolean operation with like a solid. So like that's the problem. You don't see the surface depth too much. That's why like I use this. But if you want, I can also do one thing else. Like wait, let's see. To make it like much more faster, what I can do is I just delete everything. Not everything at least. Okay. I just need this. Okay, I'll just break it to make it a little more faster. Explode. I don't know on this lines. Yeah, I need the attractor. I just lock it out so that it's not movable. Then I'm going to rebuild this so that then I'm going to rebuild again with not with 4. So okay, this is cool. So what I'm going to do is like I'm going to extrude. I can do this even in Grasshopper, but I just want to do this here. Okay, that's the problem when you extrude with Rhino. Sometimes if you do surface, which I'm not like, you can do like swoop, but I don't want to do it. Set one curve. Let's say like extrude. Unit Y. Maybe let's say like 1500, something like that. This is just a random value, okay? Oh, sorry, it's unit X. So if you want to make it like looks more parametrical, what you can do is like I'll just give an exercise. So you can explode this, and you see there's 4 curves. You just need to explode it, and you need to take list 1 and list 2, list 3. You need to remove the curves and then use the length of that curve. You can just do it. Okay. I'll just do it manually for now. Okay, now what I'm going to do is I'm going to create here. So this is much more like not so random. You can create it. I'm just waiting. I'm just filling the time because it completes. It takes some time to complete it. Okay, if you see here, yeah. Okay, you see, like it looks flat because there's no extrusion there. So what you can do is here, just relax. Yeah. So that's the problem when it's not parametric. So when I take like the values and everything from the Grasshopper itself, then I don't need to manually change it. Everything is linked. But this one I'm just giving you multiple options to figure out which one you prefer. So that's why. And you can see here now, like something like this, it's been created. So now you can do CNC printing or like laser cutting or 3D clay printing or 3D printing to get this. And the problem here is not the problem. So technically, this extrude part will always like take more time to like it is like a big load to do the extrusion. So I always disable it. I'll just first work with the curves to get more good output, and then I go with the extrusion part. Let's say like I'll just go like more depth and let's say like unlock the curve And let's make the curve a little more interesting. Apart from so you can that's what I told you. You can change the value however you want. And then you can change the surface however you want. So this is the end of the video. So you can try different combinations, different like different attractor curves, different surfaces, and you can share it in the post. And I'm going to frequently post more videos in Grasshopper. So if you don't want to miss it, please press the subscribe button and see you in the next video. Bye bye. Have a good day.